Okay, we're going to take a look at another differential equation where we need to use separation of variables to solve. Okay, so differential equations, you have dy by dx equals, and on the right hand side, if this was just something in terms of x, you can just integrate straight away. What we have here has x and y, so we need to make sure we move all the y's over to the left side and all the x's to the right side, and that's called separation of variables. Okay, so because there is both x and y, that's why I'm using this method. Here you could do it in a few ways. Like think of e to the minus y as 1 over e to the y. That's probably the best way. So to make sure that all the y's on the left, I can just multiply by e to the y. And then multiplying by the dx as well. Perfect. All the y's on the left, if I did it correctly. So that dy was just this dy here. All the y's on the left, all the x's on the right. So I'm ready to integrate. Let's integrate here. Now the integral of e to the y dy, we know the integral of e to the x is just e to the x, right? So integral of e to the y, e to the y. Integral of x squared over 2, and then we have plus c. Okay, now the question is, let's find a particular solution with boundary condition here. So any boundary condition or initial condition, what that's going to be, that's going to help us find our value of c. And you have two choices, right? You can substitute in your boundary or initial condition straight away at this stage, or you can rearrange, make y the subject, and then sub it in. In this case, my boundary condition for y is y equals ln2. And if you look at this, that's going to go quite nicely already. So I'm going to substitute in my known conditions now. Okay, so when y is ln2, x is 4. And e to the ln, inverse operations, we know they cancel out. I'm just left with 2 over here. That's 8 plus c. So c is going to be negative 6. So my final solution, it was e to the y equals x squared over 2 plus c. Take away 6. Question says give your answer in the form y equals f of x. So I just need to rearrange for y. To do so, I take a log, right? So I'm going to take logarithm of both sides. I'll get y equals natural log s squared over 2, take away 6, and that is final answer all done. So some of you will be very happy to stop in the video here. That's completely fine. If you've seen this question in the textbook and you're wondering about the answer in the book, that's slightly different. I'm happy to explain that now. So the answer in the book actually gives ln absolute value, x squared over 2 minus 6. And as far as I can tell, this is actually not correct. Okay, so if you do want to just understand about why this is not correct, you can carry on watching. If you're happy with this, if you can do all this and you're happy to switch off, you can switch off now. Okay, so in differential equations, sometimes we know we end up with these absolute values. And the situation when we have an absolute value will be something like dy by dx equals 1 over x. In this case, you just integrate both sides. Y equals the integral of 1 over x dx, which is natural log of absolute value of x plus c. Okay. Now, in this case, the absolute value has been introduced when I've integrated 1 over x. In this question we've just done, I never integrated 1 over x. I never integrated 1 over y. Okay, so there shouldn't be any absolute value as my final answer, which is why this is the correct final answer. And you can actually see this is correct just by checking the differentiating. Okay, so if you think about what absolute value of x actually means, okay, we know it means it's going to be x if x is a positive number, and negative x if x is a negative number. So this function we've come up with here, ln absolute value of x plus c, okay, that's going to be, well, let's get rid of plus c actually to make it simple. Pretend c is 0. It doesn't effectively differentiate. This will be ln x if x is positive, and ln negative x if x is negative. And I'm ignoring x equals 0 because you can't take log of 0. Now you can check this is a valid solution to the original equation. Yeah. So you can try differentiating. If this was y, then if you differentiate, well, if x is positive, the derivative of ln x we know is 1 over x. Okay. But the derivative of ln negative x, well, that's going to be negative 1 over negative x by the chain rule, which is still 1 over x. Okay, so we can see in both situations, whether x is positive or negative, this function, natural log of absolute value of x, it does differentiate to 1 over x, which means it does solve the original equation. Okay, so I'm allowed the absolute value here. I'll show you that we're not allowed it in this question, which is why the answer in the book was not quite correct. Okay, so if y was natural log of absolute value, natural log absolute value of x squared over 2 take away 6. If this was the case, well, we know this would be, it's going to be ln x squared over 2 minus 6 if this thing, this x squared over 2 minus 6 is a positive number, and it would be ln of the negative of that if not. Okay, so I'll write the negative of that as 6 minus x squared over 2. And just a little note up here, I'm going to say that x squared over 2 minus 6 is positive. You can just quickly verify that that's the same as when x squared is more than 12, which means x is going to have to be, well, let's say the absolute value of x will have to be more than root 12. Okay, so if x is more than root 12 or less than negative root 12, this will be valid. If x is between negative root 12 and positive root 12, we'll have the bottom solution. So as before, as we just did, I'm going to check, well, does this solution, does this differentiate and satisfy the original differential equation? What was the original differential equation? It was dy by dx equals x e to the minus y. So let's try dy by dx. If this was y, then dy by dx would be, okay, well, if we're in this top situation, x being more than root 12 or less than negative root 12, I'm going to have, by the chain rule, you should get x over x squared over 2 minus 6. And in the bottom situation over here, when you differentiate, you'll get negative x over 6 minus x squared over 2. So actually, it's also the same thing as before. Okay? But the differential equation was dy by dx equals x e to the negative y. And if this is y, we know what dy dx is. If you figure out what x e to the negative y is, okay, in the case where absolute value of x is more than root 12, x times e to the y, with this being y, well, e to the y will just be, in either case, right, e to the y is just x squared over 2 minus 6. So e to the negative y will just be 1 over. Okay, so in this top situation, x e to the negative y is x over x squared over 2 minus 6. That's fine. But if y was in this bottom situation where x is these values, x e to the negative y would be x over 6 minus x squared over 2. And if you look, this does not match, okay? This does not match dy by dx. The equation was dy by dx equals x e to the minus y. So in this situation, we see they match. They're both x over x squared over 2 minus 6. But down here, this is negative x over 6 minus x squared over 2, and this is positive x over 6 minus x squared over 2. So generally, it's just not a solution to have the absolute value in there. Now, all of this, don't worry if you're just taking the A level. Don't let this scare you, okay? You're very happy just to sort of stop here. That's completely fine. Again, I'll show you what's going on graphically, which don't necessarily need to do for this question, but essentially what's going on. Got our x and our y, and we've got our starting point, and our starting point was, what was it? It was x equals 4, y equals log 2, for ln2, and ln2 is roughly like 0.69, so on. So we start somewhere around here, and this differential equation that we have, that describes the kind of curve that the point can take from the starting point, and it turned out the curve goes like this and goes down, and it has an asymptote here. Okay, has the asymptote when x is the square root of 12, because we know our solution is y equals natural log x squared over 2 take away 6. Okay, and there's also kind of another branch over here. Asymptote x equals negative root 12, but obviously we started from this point. The solution sort of moves along this branch here. So that explains how you do this question, and then I've also just explained why the proposed solution in the textbook is actually not quite correct. I'm going to try and make a video every single day this half-term break, so please let me know any topics or any questions you want to tackle, and I'll try to help you with that.